Okay, we are live, and let me just double check, make sure everything's working, because I
Live,
actually,
live, live.
that's what I'm trying to set up. Live, I'm doing live and recording this time around. If I've got everything set up right, I'm double checking.
Well, I would have dressed better.
You would have dressed better. I mean, it was the same thing if it was recording or live. It would have been the same clothes you were wearing, right? But yeah, no, we are live right now. I can see us. We're going. So this is fantastic. I finally got my live setup working. I got approval through YouTube and went through all the motions, so we can do this live now, which will be fantastic.
All right.
So that being said, today this is Talking with Uncle Mike, Evolution Part 2. I am Dave, or DM Dave, as I'm known around here at Dave's World. And I got with me Uncle Mike, the analog man in a digital world. Go ahead and introduce yourself, man.
I'm Uncle Mike, still wearing a Timex. So that's okay.
I remember when you tried to tell me it was a Rolex, but I told you, nah, Rolexes don't tick.
Yeah, exactly. Exactly. Fake ones do.
What, who does?
I said fake Rolexes do.
Oh yeah, the fake Rolex, yeah, the Folex.
Yep.
So, when we last left off, and unfortunately, I know the audio quality was a little garbled. We didn't have our setup as good as I would have liked it, but now we've got ourselves more appropriately spaced out, so we don't have mic interference or any of that issue. So go ahead.
No, way better.
Way
You
better.
got it dialed in, Dave.
I think we do. Yeah, this sounds way better. So, when we last left off, we were talking about evolution. We went through some basics about just kind of like explaining how natural selection works in general. And we talked about theory, law, hypothesis, idea, fact, kind of getting some of the nomenclature a little bit better understood. And yeah, so now we're going to go back and think of some questions to kind of come back to the table with, and for things that you feel like you need expanded upon regarding evolution, right?
Yes.
All right.
Yeah.
So
It's basically it's only one question, but it's got a couple of parts in it.
well, before we get to your multi-parted question, why don't you can you share what you retained from last time regarding when we were talking about natural selection theories? Doesn't have to come in any particular order. Just like what are the things that you felt like you did take away strongly from in our last conversation?
Well, the survival of the fittest
Okay.
is basically what I
Uh-huh.
and basically breaks things down into ages. That's why. Well, that ties right in with my question. The first time a Homo sapien is seen or spotted or aged with carbon-14 half-lives is the beginning of an age.
Okay.
And
So I see where you're coming from. So let's set the carbon dating to the side for a second. Let's talk about the ages, right? You may hear some different terminologies regarding time, especially on a geological scale, right? When we're talking about a planet that's existed for over 4 billion years, breaking those periods of time up into different time frames is a little tricky, and it's hard to understand. You might hear terms like age, epoch, It really depends on how long ago and how much time. And honestly, I don't feel like dwelling on that is too important.
What?
But so you're talking about you want to know when Homo sapiens first arrived on the planet is or not arrived, but
No.
the earliest evidence that we have of Homo sapiens, right?
Well, we were talking about survival of the fittest,
Mm-hmm.
you know, and I was now when in my brain when end of an era, beginning of a new era, then they have better technology, better weapons, better sticks, better rocks, yada yada, fire, yada yada yada, and then they wipe out the previous age, survival of the fittest,
So
and then
so we're talking. You're talking specifically about hominids, right? And I definitely feel like bringing hominids into the equation right away is a little advanced before understanding the basics of survival of the fittest, right?
okay, then my question slash statement is going to be the precursor to that conversation.
Fantastic, fantastic. So, so let's start with what is survival of the fittest? What is fitness, right? Now, a lot of people conflate this term because they have a more colloquial understanding of what fitness is. We think, oh, fitness like a fitness regimen, getting bigger, stronger, pumping iron, getting swole, right? And that's not what we're talking about when we're talking about fitness. When we're talking about fitness, we're talking about fitness for the environment that you exist in, right? So, a shark is fit for the ocean, very fit for the ocean, but not so fit for the desert, right? You bring a shark into the desert, you don't have a shark anymore because it is not fit for that environment.
Right.
When you gain fitness in one environment, you necessarily lose fitness in another. And I know this is something you've heard Forrest Valkai say, right? When we've watched some of his videos. And that's what he's talking about, right? If you are suitably fit for a particular environment, you are suitably fit for that particular environment. And going into another environment would wipe you out. You can't just bring penguins to North America and expect them to survive. They are fit for the Arctic freezing weathers of the South Pole, right? So, and even when we put them in zoos, right, we have to make their environment fit what they are adapted to. So that's what we're talking about when we talk about fitness, right? Survival of the fittest is whoever is best suited in that environment to reproduce and pass on their genes. Survive and reproduce, and then once you've reproduced, technically, you've done your part. You are I'm not going to say useless, but you are no longer necessarily contributing to the evolution of the species.
Right. You wouldn't throw a bunch of Homo sapiens in the ocean.
Yeah, yeah, exactly. We would die out in the ocean after not too significant of a time, right? It's kind of hard to survive out there when you don't have the things that you need to make it. So that is fitness, and of course, like I said, it's all about surviving long enough to reproduce. And once you've done that, then it's about the next generation surviving long enough to reproduce, and so on and so forth.
Yep.
All right, let's get to your question then. Let's go ahead and dive right in. Go ahead and share what you got.
Okay. Uranium half-lives and carbon-14 dating. how accurate are they? 100 years, 1,000 years, 10,000 years, million years. What are we really looking at here?
Okay, so that's an easy question. The amount of time. First of all, it's incredibly accurate. You can go because now carbon 14 as it decays to carbon 12 is its half-life is significantly shorter than the half-life of uranium 237. So because its half-life is so short, it decays much faster. And if it decays faster, once you've got a sample that has decayed all the way to carbon 12, it's just going to keep being carbon 12, and it's going to have that same it's going to be at 0, right? You're going to have 0 carbon 14 isotopes to count.
So basically a gaps.
Well, now carbon 14 is mostly just used for things that are made of wood, paper, cloth, those kinds of things, right? Because it decays so fast, and it is not a reliable isotope to go back more than, I think, 5 to 10,000 years, somewhere around there.
Okay.
But uranium 237 has a half-life of lot long. I'd have to look it up. Hold on. Let me see. What's the this is actually why I got the little Google here ready to go. Let's see. Uranium 237.
Dave, you're buffering quite a bit.
I'm buffering? What do you mean
buffering.
by I'm buffering?
Meaning you get hung up.
Oh, can you hear me now?
You're stopping. So I can hear you, but it's the video is getting hung up.
Oh, that's probably because I went over to Google really quick, and it yeah. So, okay, sorry. I did have this backwards somewhat. Uranium 237 is what it's decaying to, not what it's decaying from. So the half-life of uranium 238, which is what we use to well, I mean, we're using both of them technically. We're using 238 in a sample size. You measure how many isotopes of 238 there are, how many isotopes of 237 there are, and you can backdate how far how old the thing is based on how much has decayed from the sample. So the decay rate is of 238, uranium 238 is 4.468 times 10 to the 9th power years. So that is man, I cannot do that math in my head, but it is a lot.
Just don't look at me.
Anyway, but and uranium 237, of course, this is actually this is a very radioactive element. It's not something we're actually using for metric dating, radiometric dating. It's something we use for nuclear bombs. So when we're looking at radiometric dating, okay, so here we go. You asked how accurate, right? You asked how accurate it is. I've got some info here. So accuracy, how accurate is radiometric dating? Radiometric dating is generally quite accurate, but it's not perfect and can be influenced by various factors. For suitable samples, errors typically amount to a few percent of the age result. For example, a date of 200 million years is likely to be accurate within a few million years. However, some methods have limitations, and contamination or other factors can sometimes lead to incorrect results. What are they using in fossils, though? Radiometric dating for fossils is not going to use carbon-14. It's going to use, which is the... Ooh. So, also, to be clear, typically they are not dating the fossils themselves necessarily, but rather they are dating the rock that the fossils are found in, right? When did this thing get covered by a bunch of mud that eventually turned into rock and surrounded it? I'm trying to find the actual element that they're using for like dinosaur fossils. I can't remember what. Oh, fossils for sale. That's cool. Okay, yeah, here we go. Most people are familiar with carbon dating. Carbon dating is rarely applicable to fossils. Carbon-14, the radioactive isotope of carbon used in carbon dating, has a half-life of 5,730 years, so it decays too fast. It can only be used to date fossils younger than about 75,000 years. Potassium-40, on the other hand, has a half-life of 1.25 billion years and is very common in rocks and minerals, making it ideal for dating much older rocks and minerals. So potassium-40 is what they are using for...
Billion with a B?
Potassium-40.
That's B, billion with a B.
Yeah, no, yeah, 1.25 billion years with a B. That is correct. Right, whereas carbon only has a half-life of just under 6,000 years. So if a sample of carbon-14 is losing half of its isotopes every 6,000 years, right, eventually it's going to get to the point where it is just all decayed down to carbon-12, and after about 75,000 years, you just aren't going to have enough isotopes left to do a count. Right? You're not going to be able to detect enough isotopes to get an accurate measurement. So that's why for older stuff we use potassium-40, because like it says, it has a 1.25 billion year half-life, meaning it decays much slower. And since the Earth is about 4.5, almost 5 billion years old, give or take, we haven't even gotten close to all of that potassium-40 decaying yet. Not even close.
Right. Okay.
That help?
Well, that was basically, you answered my question, because I was saying it was pretty much a fill-in-the-gap process, because they've got stuff, age tested at a certain age, and so when they do these other uranium half-life like that, they're able to line them up per age.
Oh, what just happened?
Pretty much, and when looking at all the it's pretty much a crapshoot when you're looking at all the accurate answers. It all comes down to who a person wants to believe, pretty much, because they trust their work. I researched a little bit.
So I see. I see what you're saying. I don't think it comes down to what a person wants to believe or who you trust. Now, because remember, the scientific method is all about repetition and peer review and oh wow, it looks like my camera did freeze. Let's fix that. Fixing the camera. Yeah, so as I was saying, it's all about repetition and peer review, right? It's not a like, oh, this person said this thing and they're a really smart guy, so I trust it. It's this person said this thing, did this research, and then this other person took that research and tried to recreate the results and see if they got the same results or different results, and then another person tries to see if they can get different results or not. The key to science is that you are always trying to disprove yourself. You're trying to find ways to disprove your hypothesis, to put the hypothesis to the absolute test, so that you know that these things are
That's
irrefutable, right?
Mm-hmm.
One of the things I like to say, like, about when it comes to a scientific theory, right? If somebody were to prove something that has been elevated to the level of theory to be incorrect, it would completely change our understanding of whatever that subject is, because the things that you have to go through, the rigorous testing and peer review and repetition and over and over and over again, in order to be elevated to a theory, this thing has to not be proven wrong after we've thrown everything we can at it. Right?
That part I know. I remember that.
So why do we know evolution is true? Because every time we test it, everything we do to try and make it like, you know, put it to the test and see if it holds true, we can't prove it wrong because it's happening.
Yeah.
One of my favorite experiments that I read about, that I want to say it was done, I think it was San Jose State? I could be wrong. But they did an experiment with basically a giant petri dish that was the size of a table. And they used E. coli bacteria, and they started on two ends of the table and put different concentrations of antibiotics. I think it was like every few inches, right, on the table, until they got all the way down to 100% concentration of the antibiotics in the very center. And when you look at the picture, let me see if I can find that picture. That's a good picture. I'll keep talking while I'm looking for it. But when you look at the picture, you can see how the E. coli was growing through the antibiotics, and you can see some strains dying off and other strains pushing through. And E. coli evolution.
It's a good thing that no strains broke through when you're using 100% max antibiotic.
Right, yeah, exactly. Yes, here we go. The E. coli long-term evolution experiment. Yeah, there's the photo I'm looking for. Perfect. Let me turn Google back on. So check this out. On the right-hand side here. Oh wait, you can't see it. I'm stupid. Only I can see it. I know what I can do. I'm just gonna DM it to you so you can see it. The audience can see it, but let's make sure Uncle Mike can see it too.
Gonna have to take a pee break here soon.
Oh, that's fine. So that image I'm sending to you is what the table looked like at the end of the experiment. And if you zoom in on it, you can actually see it looks like an evolution tree. Like, you know, the charts where they show like the species came from this species and from that species, etc. You know what I'm talking about? Those charts that show that show like where the familial relations are on various species types. Well, if you look at this, it kind of looks like that, right? You can see it branching off into like these different strains.
Went over that.
Yeah.
Yeah, Valkai went over that, remember?
Yes, I do.
Yes, I do. Evolved from a frog, you know, potentially.
Well, it's not saying that we evolved from a frog. The way those charts are trying to classify and categorize things is it's saying, like, okay, mammals are more closely related to birds than they are to lizards. Lizards are more related to frogs than they are to fish. Right? That's the nature of the relationships they're trying to demonstrate.
I need to take that break now.
All right. Handle your business, and I'll keep the audience entertained for a bit.
Yep.
I don't know.
Is there
anybody in the live? Maybe there are people chatting in the live. Maybe we're getting some attention. I don't know.
I need to take that break now.
All right. Whoops. Now, nobody in the chat. Hello, all who want to get that no scope without shaking all over the place. And if you go to w.gg and purchase with coupon code SPUTTER for my gaming channel Sputter Media and checkout, you will get 10% off of your order, and you can support the channel because we get 10% of the order too. So you get 10% off, and I get 10% of Dubby's money. It works out really nicely. We're just waiting for Uncle Mike to return, but yeah, if you got no plans tomorrow evening, we will be doing Friday Night Fireside, as always. And if you enjoy Friday Night Fireside and want to participate, then you just need to join the Dave's World Discord server, which is linked also in the description. Or find me, Sapper12B on Discord, and I'll shoot you an invite. I haven't decided what I want to talk about tomorrow. I've been kind of thinking, like, maybe doing an episode on the Matrix. Like what about like, what if we lived in a simulation? Not that I think we do actually live in a simulation. I believe it's fiction, but I think it's a fun thought experiment to talk about that stuff and maybe talk about some of the elements of the Matrix series that have been weighing on my mind a lot lately for reasons. I don't know why. I can't explain it exactly. But for some reason, I've been really fixated on the themes of the Matrix. There's lots of themes, and I couldn't put my finger on any one particular. But of course, the main ones that we're always thinking of is free will versus destiny. Do we have free will, or does everything go according to some plan? I don't know. I'm more inclined to think that we do have free will, if only the illusion of it. I don't believe that destiny is a thing. And man, can I just say the red pill thing is bugging me. I have a lot of things to say about the red pill thing, as it applies to our current society. And I think Mike accidentally oh, now he's back. There we go.
Look, I get the clicking.
Yeah, you need to turn your camera back on though.
How?
If you look down below in the channel, you'll see next to the microphone there's a picture of a camera, should have a line through it. Click that.
Uh-huh. That. All right. Yeah, I keep forgetting that when I start clicking, the computer has to do all those functions that I just clicked.
Yeah, it'll do that. It'll do that, especially when you got an older system. I still don't have your camera on though. You got to click the camera and then oh, there we go. Now it's turning on. Hey, here he is.
I learned something.
You did.
It'll be gone by the time I leave here.
I know.
Yeah, I did learn something.
So anyway, so like I was saying, with the experiment regarding the E. coli and showing the different generations of E. coli and how they kept pushing through the antibiotics, right? They kept consuming the medium of the petri dish and kept pushing through the antibiotics and evolved into strains that were more and more resistant to the antibiotics, which of course is a really, really good visual demonstration of why you should always take your full bottle of pills, the bottle of pills that they give you for antibiotics. Like this demonstrates exactly what the danger of not taking the full 100% of your antibiotics that you're supposed to take, because
I feel fine. I don't need to.
well, no, but yeah, no, that's the problem. No, that's the problem. People are like, oh, I feel fine, or the infection is visibly gone away, or whatever. But the problem with that is that the only bacteria of the infection that are going to survive are the most resistant ones if you don't take the whole thing.
Yep.
Yeah. So, okay. Do you got any more questions? Let's see. More questions about evolution. Let's keep talking about evolution.
Well, I got bits and pieces filled in.
Mm-hmm.
Okay. I know we did not evolve from a frog. I know we are closer to a bird than a lizard.
Yes.
I know that. I saw the whole Valkai 4 episode in my garage.
Yeah, I know. We watched that.
There are a lot of things. I mean, I got the theory has been attacked by everybody to try to refute it. That's
well, I will say it hasn't been attacked by everybody. It's been attacked specifically by religious creationists. The only people who have any issues with the theory of evolution are religious creationists, and for the most part, those are in the big three. You will have creationists that are Christian, Jewish, or Muslim. Particular because they are all from the Abrahamic
Dave, you're bad.
I was what?
Buffering.
Yeah,
Where it shows motionless Dave. I can hear you because you're in the other room, but I can't hear you through the microphone.
How about now? How about now?
Yeah.
Yeah, that'll just happen from time to time when we get a little bit of a connection issue.
Okay, I didn't know if it meant that we got to be farther apart or not.
No, nothing like that. So where was I? Yeah, so mostly it's only under attack from fundamentalist creationists, people who are either young Earth creationists or those who try to promote the fine tuning argument or whatnot, or the argument from complexity, trying to suggest that this universe is too complex or the human body is too complex. It has to have come by a creator, which is absolutely nonsense. But we could talk about that if you like.
No. We need to talk about that. I mean, so the Ice Age was after the big asteroid or meteor.
Okay, well, we're definitely separating these events by several billion years here. Well, not several billion, but the Ice Age. The Ice Age is only about it ended only about 15,000 years ago.
Right. They still had the woolly mammoth.
Yeah.
You know.
And dire wolves. Dire wolves are all the rage right now.
Well, we got one at 0.0001%.
Yeah, and don't get me wrong. I wouldn't hate to talk about this, the dire wolf thing, because for those who don't know, scientists recently, I can't remember what company they work for, but they recently cloned a dire wolf or dingoes. It's actually more closely related to those canids. And so these dire wolves that they created aren't even actual dire wolves. They just look like the dire wolves from Game of Thrones. That's it. They look like the dire wolves from Game of Thrones, and they're calling them dire wolves, but really they are just modified gray wolves.
Okay.
But it's still fascinating. It's still fascinating that we're able to do all this shit.
Yeah, but didn't we clone a sheep?
Yeah, Dolly the sheep. That was back in the 90s. Yeah, that was back in the 90s, yeah.
So what's the deal with the big gap of, this time? So what's the deal with the big gap of, this kind of technology? I mean,
well,
in the 90s, we cloned a sheep. I mean, what I'm getting at is, how come we can't make cows feed the people of the world? Or why can't we make a tomato this damn big? Stuff like that.
Ooh, that's
feed people.
Okay. So yeah. Well, one thing I will say when we're talking about stuff like cows or animal livestock animal, it is just not cost effective to do it genetically rather than the old-fashioned way when we still have cows, right? So when they cloned the sheep, that was just, proving out the technology, right? Like okay, our technology is here, and I want to say it's not that there's been a gap between these things. It's not. We've been doing research. We've been studying genetics, and CRISPR technology was probably like the halfway point between Dolly and now, because CRISPR technology is what allowed us to actually do gene editing, right? Because this isn't a clone. This isn't a clone. This is completely different technology, right? They're not cloning a dire wolf. They edited the genes of a gray wolf to make it bigger.
And white.
Hmm?
Wasn't it white?
Yeah. Oh, and it's
Took a
white.
gray. Yeah,
Well,
took a gray wolf, and then it's white.
Right, but gray wolf is the name of the species. There are white gray wolves.
Okay. Don't get me started on that.
Oh, Cindy's with Cindy. Do you want to join the conversation? You are more than welcome to if you like. I'll invite you up here if you want to jump in, chime in on any of this. Nope, she just wants to listen. That's okay. You're allowed to just listen. You are welcome to do so.
Sure.
Okay. So yeah. So the these dire wolves are just bigger wolves through gene editing, right? Which is different from flat out cloning. Now you asked the other question: why can't we make gigantic tomatoes? Right? That was a valid question. Why can't we just make like huge freaking tomatoes? And that is because there are limitations with the plant itself, right? You can't get a plant to grow fruit bigger than it can support on the vine, right? If the tomato gets too big, it's just gonna pop off, and it's just gonna fall off the vine early, right, before it's ripe. So there is a limit to how big we can make these things when it comes to editing, genetic modification.
There are ways to horizontal vines. Look at these giant pumpkins that you'll see.
Right. Okay, but pumpkins grow on the ground, right? Tomatoes grow on the vine. If you
Vine, but you can have it horizontal to the ground, the vine. So it wouldn't be too much for the vine to take.
So then you would just have all the tomatoes growing on the ground, but they're not protected from the ground. Like a gourd is. A gourd has that big shell.
My dad's backyard has it. And he grows the biggest beefsteak tomatoes I've ever seen in my life.
Right. I'm not saying you can't grow them big. You can grow them big. I'm saying there's a limit, right? We can't get them like crazy huge. There's a limit.
Okay, you answered that part of my question. Yeah. But we can make bigger food.
Sure. Within
just a little bit,
I want to say, to be perfectly frank, the GMO industry has been doing that for quite a while now. Like we have bigger, more nutritious, tastier foods that exist because we have done that.
A GMO cornfield in Pennsylvania. The stalks are identical.
Yeah.
The cobs are in the same spot on each stalk. I mean, it was like kind of eerie.
Oh, to see how they're all like damn near identical instead of because there's no variation. There's no variation in their genetics. They're all literally all the same seeds.
You see the cobs on the same spot on the stalk.
Yep.
That was like, oh my goodness, what's next?
I mean, but that's again, that's something that you would expect when you have a bunch of clones of the same seeds, that you're going to get a bunch of the same plants, right? They're going to look damn near identical, as opposed to like, Mendelian genetics when he was messing with the pea plants, right? He was crossbreeding tall plant with short plant, with fat plant, with thin plant, with, well,
like mustard seed. The mustard seed is not just, it's been cross-pollinated.
Yes.
With I forget what seed. Flax seed?
Yes. So, and building on that, mustard plant, the mustard plant is been artificially selected over thousands of years to give us the various greens that we tend to eat, like broccoli, lettuce, cabbage, cauliflower. All of these, Brussels sprouts. All of these different foods are all the same plant.
That's right. I heard that.
Because it's just like how we've been artificially selecting wolves for thousands of years to be dogs, right? We were breeding the animals that had the most desirable traits for whatever we were using them for, whether it was for security, defense, hunting, or just companionship because you want a little teacup poodle, whatever. We've been doing that for the last 10,000 years, and now we have domestic dogs. We did the same thing with mustard, and now we have lettuce. That's how, and this is all to the whole conversation about evolution. Why do we know evolution is real? Because we do it. We've been doing it for thousands of years. We have been using evolution to our advantage. We've been using the ability to decide what traits we want to breed in or out of different species to get literally everything